I can't wait for the 10-minute report.
So we have less than 10 minutes to go. So what I intend to do with these 10 minutes is do an experiment of a new way of teaching classes.
10 minutes or less.
Like a YouTube video. Perfect.
Pizza day.
Okay, so this is what I want to do. So what I want to do is, let me go to Moodle first. All right. Okay, there we go. Okay, I am trying to experiment with this way of teaching a class. Not just this one, but also with all my other classes. So I'm actually putting new notes into probability, not discrete probability, but this part here, probability. I know I'm supposed to talk about recursion, but since I did prepare this note here, and it does have continuity to what we are talking about, so I'm going to get to this part. So I have two documents. The first one is just a regular document. It is published from Google Documents, but it nonetheless is really just a web page. It's completely static. You don't have to sign in to see it. It's just like a web page. The second link is a Google document. You have to sign in to apps.losrios.edu first before you can actually open that link. But if you do sign in and you open this link, it is a Google document, which means I turn off editing, so you cannot go in and just Control A and Control X the whole thing. The worst part is not doing that type of thing. The worst kind of thing is just to put an add one somewhere, in the equation where it does not belong. That's poisoning, which is what Microsoft is really good at. So instead of saying we are not going to follow TCP/IP or we won't do Java the way Java is supposed to be, they poison the standard instead. They would say, yeah, we follow most of the standard, but we'll change these conventions a little bit. Okay. So, but you can, comment. Okay, so that's the whole point, is you can comment on it. So that means, when you get into this document and you go like, I'm not really quite sure what it means by blip. This part here, you can comment. You can just highlight and write down your comment, and then I can see your comment and I can address it and resolve it. So it makes the document kind of semi-interactive. And it can be interactive during class. It can also be interactive as you study offline. Well, online, but out of the class. Okay? So it's my new experiment. I'm not really sure how it will turn out, but we'll take a look. I mean, I'm willing to try.
So instead of raising your hand to ask a question, you can just highlight it in real time.
Exactly. That really is the whole point. I mean, literally, that really is the whole point. Okay, so what we'll do today is we'll get started with conditional probability, okay? And I'm not really quite sure how to zoom in with this one. Okay, so this is also something that I can do is in class for presentation. I can use just the web document so I can zoom in, but on your device, this will work on the cell phone as well, by the way. On the cell phone or on the tablet or on the computer, you guys can work with the Google document and highlight the portion that you have a question about, and it's just right click and go, okay, I've got a question about this. I'm not really quite sure what you meant by that, blah blah blah. But I'm going to have to use this one for the in-class presentation because of the ability to zoom in. Okay. All right. So we're talking about conditional probability, and this is what I don't like about Google Documents is the equations look really fuzzy because they're just images. It serves the purpose, it's not ideal, but it's okay. So what we want to do is to define a predicate called AX, which is, and if you remember what a predicate is, it is something that can either be true or false, okay? So A of X can be true, A of X can be false, that's all we can do. And in this case, X has to be an element of some kind of omega, which is the set of all possible outcomes. Okay, so it's still using the same terminology as when we talk about discrete probability. It's just that on top of omega, which is the set of all possible outcomes, now I define A of X as a predicate. Okay? So A of X can be true, can be false, and then I define B kind of the same way, is another predicate. And to simplify the notation, I define A itself as a set, so that A is a subset of omega, so that if an element X is in the set A, that means the element X is also in omega. Well, that kind of goes without saying. But the most important part is A of X has to be true. Yep.
Go back to when you introduced that like little symbol. Does that necessarily mean that X has to be an element of the little fancy F? Since F was a subset of omega?
F?
F was, because omega was the set of all events. And then F was a set of events that we were concerned with.
Right, so A is replacing the F, but we have multiple things that we are interested in, so I got away from just using F. I use A and B in this case to denote what we're interested in, okay? All right, so now we have two sets, okay? Set A is a subset of omega, set B is a subset of omega. Now these two sets can intersect, they may not intersect at all, okay? They're just two subsets of omega. They may both be as big as omega, okay, which usually is not very helpful in that case. But here's the definition. The definition is the conditional probability. This is the conditional probability. P A bar B is the notation of A being true while B is known to be true. What are the chances that A is true when we are already given that B is true? Okay? Is defined to be the probability of A and B, or A intersect B, divided by the probability of B. Now, since the probability is the cardinality of a set divided by omega, so I did one step of simplification without saying it. Basically, the top, this part here, this is the cardinality of A intersecting with B, but the probability is, it really should need a divided by the cardinality of omega. But the same thing applies to the bottom. This is the cardinality of B divided by the cardinality of omega. So the division by the cardinality of omega would cancel out. So this ratio is what is left. Are we doing okay so far with conditional probabilities? Okay. So why do we need to know conditional probability? I'm skipping Bayes' theorem for now. Yep.
Conditional probability is that when like an occurrence of one effect or one event will affect the probability of occurrence of the second.
Not necessarily. It's just.
Well, what's the concept of conditional probability?
Okay, so here's an example. Some of you like this one. Some of you go like, what? String copy. Okay. So this is all made up, by the way. Okay, the numbers are completely made up. Okay, so the cardinality of omega would be omega itself is the set of all published software written in C or C++, and I'm assuming there are 400,000 of those. Okay, is that okay? Just an assumption. Okay, A is denoting. Let's see, where's A? A is denoting. A is supposed to be the number of software that makes use of string copy. So, so exactly 1/2 of all published C and C++ programs make use of string copy. It's an assumption. It's just made up, completely made up. Okay. Okay. B is the number of programs or number of published software, including all versions of the same software. Okay. Is that 20,000 out of 400,000 software that is published, written in C and C++, has serious security vulnerabilities. Okay? And A intersect B is 19,000, which means if you look at the set of all software that has serious vulnerabilities, and you look at the set of all programs that has string copy in it, the intersection, okay, is 19,000. Yep.
You said that the cardinality of B is the amount of software that is vulnerable because they don't use string copy?
No, there's no because no nothing. They just have security issues. Okay, we don't know why, but we know that 19,000 titles is the intersection between software that makes use of string copy and software that has security issues. Okay, so now we want to look at the conditional probability. So PA bar B, which is this part here, is asking what is the probability that a program has what is A again? A is making use of string copy, given that it has vulnerability to begin with. Okay. In other words, out of the 20,000 titles, okay, I throw a dart to that list, pick a particular title, and then I ask the question: what is the likelihood that this particular program makes use of string copy? Okay? And if you all look at the calculation, the chances turn out to be 95%. Once again, remember the numbers are all made up, so they may be exaggerated. Okay? So you look at that and go like, okay, so if I pick any program that has security vulnerability, there's a pretty good chance, 95% chance, that it contains some kind of call to string copy. Yep.
But this isn't saying that the vulnerability is caused by string copy, it's just
Nope.
saying that it's likely
Nope.
that the two.
They just hang out together. That's all it's saying. Okay?
Just hang out.
They just hang out. Yep. So what I also do is to compare the chances of a program being vulnerable if it is known to make use of string copy. So that conditional probability, knowing that a particular program makes use of string copy, you have a 9.5% chance that it also has a serious vulnerability issue. Then go like, well, we don't know whether that really is because of string copy or not, right? So you look at the other one, which is, okay, let's look at all the programs that do not make use of string copy, and look at the chances of what are the chances of this program having a security vulnerability. That turned out to be 0.5. So there's a correlation, okay? I cannot say it's a causal relationship, but there's a correlation that if a program makes use of string copy, it has a 19-fold probability of having a serious vulnerability problem. But that's just, it's a correlation, okay? It has nothing to do with causal relationship. In other words, it is not saying, oh, string copy can lead to Stack Overflow, blah, 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 and that's why these programs tend to be more vulnerable. It could be many other reasons, okay? But it's a correlation that strongly indicates there's some kind of linkage between the use of string copy and a particular program being vulnerable. Okay? So, but this is the application. Now, I just came back from the Highway Patrol office in South Sac to get my collision report and stuff like that. So this just reminds me of insurance, automotive insurance. They do this all the time. Okay, they look at the conditional probability of, okay, let's say somebody drives a Mercedes SLK 500. Okay, what is the likelihood of that vehicle getting involved in an accident? It's just a number. Okay, and then they look at, okay, given that somebody is driving a Mazda MX-5, what is the probability of that vehicle having an accident? It's just a number. Is there a causal relationship? I don't know. Maybe there's one, maybe there's none. But they look at those numbers to determine your premium. But that's not the only thing. The make model is a part of the equation, but that's not the entire equation. They also look at other things like the age of the driver. They look at, well, obviously, DUI records of the driver. They even look at the grade point average of the driver. So here comes another reason why you want to bump up your GPA, because you might get cheaper insurance for driving your cars. But look, they look at all the factors, okay? And then they make up your premium. They determine your premium because of that. That is a strong application of conditional probability. Okay? So there are a lot of real-life applications of conditional probabilities. So I'm going to stop the lecture now because I'm over by 5 minutes, and then some people need break before the next class too. I cannot do